It is past midnight for Saturday, October 25th. I'll be honest, I don't feel great right now. I'm hurt. It's getting better today. It's manageable, but it just sucks. It also has the mental effects of being injured and not being able to, and also coming off of just a bad game yesterday, but then not really sure if you're going to be able to play the sport that you really enjoy playing and the people you're going to be around. It's also that weird that and also that kind of guilt, am I good enough to play? Because if I am good enough, then I really contribute to the team itself, really contribute to the team. So it's complicated. And there's also this really weird factor where I just really like hanging out with the team. And I'm afraid that if I'm hurt and not playing anymore, then I just won't have time I won't have the ability to really hang out with them anymore. But outside of that fact, that just overall, just bad feelings, physically and mentally right now, I'm doing CompSci work. And so CompSci work you would think would be coding. And this class is just not. Sure, I have to code up a simulation of predator-prey interactions with also hunting things as well, but it's pretty much just predator-prey interactions, and it's not inherently difficult to code up, but it is so theoretical in a way that I had to stand up here and do math for about an hour to figure out what I actually am supposed to be coding. What the actual thing that this is modeled is, it's what is it called? I'm looking through my notes, is the Lotka-Volterra model. And so that is it's not difficult to understand. It's the predator-prey interactions is that predator's birth rate is dependent on the amount of prey, because there's more food, there's more births. And the predators only die from their death rate. And the prey is, they just kind of have a birth rate. And the more prey there is, the more of them there are, the more birth rate there is. And then the death rate is, they also just die too, but the more prey, the more predator there are, the more they get eaten. So it makes sense, but it's a complex thing to think around. And so I just did some things, and I also had to do stuff to find the values of the populations Y and P to make sure that they are at equilibrium. And equilibrium, you would think, means that it kind of oscillates at the same distance, but no, in this instance, equilibrium means that the rate of change is zero, meaning that the populations do not change at all. And in this model, there are two ways that the population does not change at all. It is both of them are just dead. There are none of them left. Or when both of them have certain constants and multiplying factors that are in this equation to be a certain thing. It's really their population equals a certain number, and that's dependent on some constants that we have to implement ourselves. And so that works. It really is kind of confusing why it works in some way, because some of it just doesn't make a little bit sense. They're not the same, which is interesting. They also the predator has a minus in a variable that the prey does not have a minus in, and it's kind of weird. I don't really understand it, but I know that this math works out. The math should work out in this instance. It very much should work out here. So that's what I'm going to do. And I also have to do a write-up about it. So I just spent an hour and a half doing CompSci work without actually coding, which is so frustrating, because this class is interesting. It is very intellectual. It is very theoretical, but I really enjoy coding. I like making something. We had to do this thing in one of the homeworks 2 weeks ago, where it was create a simulation where it generates a bunch of dots around in a plot. Then you need to estimate the value of pi by the ratio of dots within a circle versus the ratio of dots outside of a circle. And I came up with that on my own kind of in like 30 minutes. And that was so fun because I could just code it up and I understood it. This will be more difficult. Like it won't be hard to code up, I do not think. Because to create, I know exactly what this should look like. Like, I know what this should look like because the Lotka-Volterra model is pretty simple. I understand that movement. But to plot this, the only thing that it's kind of weird is the fact that the population change of the predator is contingent on the population of both the predator and the prey, and vice versa. So the prey population is contingent on the population of the prey and the predator. So they're kind of intertwined with each other. So when I'm writing this code, I have to compute one first. And so that's going to be interesting. And right now I can't visualize how it would really be. Like I can compute the change in population, then I will update the population. But do I compute the change, and then update? Or do I compute, update? I don't know, it's going to be confusing, but that's where I'm at right now. So I don't think it's going to be difficult, but it's just odd. I want to go back to coding. I want to go back to like data science and just putting words onto a computer screen and it coming out with something. But yeah, I'm probably going to code this up in a little bit, go back, just take a shower, and don't wash my hair because I don't want to wait for it to dry. But then sleep and then do this all tomorrow too because I have stats homework and Japanese homework to do. So that's going to be fun.